Alright, today we'll be going through the review for topics 1 through 4 for the test on Friday. For numbers 1 through 4, state if the graph falls above or below the horizontal asymptote, state if the graph represents exponential growth or decay, state the equation for the horizontal asymptote, state the domain, state the range, and then graph. Okay, so pretty much everything for the graphs. So f of x is equal to 2 to the x minus 3. A, B, H, K. So A is 1, there's no number in front. The base of the exponent is 2. The H value is up here with the X, which is 0, and the K value is out here at the side, which is negative 3. That tells us that the horizontal asymptote is negative 3, it's the K value. When we start our table, in the middle of our table should be the H, which is 0, and then negative 1 and negative 2, 1 and 2. So plugging in negative 2, I'm just going to use y for this instead of f of x and make it a little bit easier on myself. Y is equal to 2 to negative 2 minus 3, which is 1/4 minus 3. And of course, you can just put this in the calculator. Okay, if you want to put this in the calculator, that's fine. So that is negative 2.75. All right, plugging in negative 1. Y equals 2 to negative 1 minus 3. This is 1 over 2 minus 3, which is negative 2.5. Plugging in 0, 2 to the 0 minus 3, 1 minus 3, which is negative 2. Plugging in 1, 2 to the 1 minus 3, which is 2 minus 3, which is negative 1. And then plugging in 2, 2 squared minus 3, 4 minus 3, which is 1. Okay, so these are all of our points. Our horizontal asymptote is at negative 3. Negative 2, negative 2.75. Let's see. Negative 1, negative 2.5, 0, negative 2, 1, negative 1, and 2, 1. So like this. So letter A falls above or below. Well, of course, this is above the asymptote. B, growth or decay. Well, this is growth because, I mean, you can tell from the graph it's growth. Decay would be coming down like this. You can also tell from the A and B values. A is positive and B is greater than 1. C, equation for the horizontal asymptote, y equals negative 3. D, domain, negative infinity to infinity. That's the same every time. E, the range. Well, the range is above the asymptote, so it's going to be from negative 3 to infinity. F would be graphing it, which I have right here. So that's number 1. Whoops. Number 2, y is equal to negative 2 times 1/4 to the x minus 1 plus 1. A, B, h, and k. A is -2, b is 1 over 4, h is 1, because remember you're subtracting 1, because it's x minus h, so that's just positive 1, and k is positive 1 as well. So the horizontal asymptote, y is equal to 1, the k value. Okay, our table, the middle of the table is going to be whatever makes the exponent equal to 0, which is the h value, so that's 1. So to the right of that is 2 and 3, to the left of that is 0 and -1. Now we will start plugging in, so -2, 1/4 to the -1 minus 1 plus 1. It's -2 times 1/4 to the -2 plus 1. I'm going to use a calculator for this. So 1/4 raised to the -2 power 16 times -2 plus 1, that's -31. Okay, let's plug in 0. 0 minus 1 plus 1, -1 plus 1. Let's put that into the calculator. So 1/4 to the -1 power times -2 plus 1, -7. Okay, let's plug in 1. So 1 minus 1 plus 1. So 0 plus 1. So that's -2 plus 1, which is -1. Plug in 2. 2 minus 1 plus 1. 1/4 to the 1 plus 1. Is 0.5. All right, and then plugging in 3. 3 minus 1 plus 1, so the squared plus 1. So 1/4 to the second power times -2 plus 1 is 0.875. All right, a horizontal asymptote is at 1. -1, -31, okay, that's a little too far off the graph. 0, -7 is right here. 1, -1, 2, 0.5, and 3, 0.875. So my graph is going to look like this. And of course, let's take a look at all the information. A, this is below the asymptote. We can see that it's under the asymptote. B, growth or decay. Well, this is neither because it's A value is negative and it's below the asymptote, so it's neither. C, y equals 1 for the asymptote. D, domain, and of course negative infinity to infinity. Letter E, the range. So it's actually below the asymptote. So it's going to start at negative infinity and it's going to go up to the asymptote, which is at 1. And then F would be the graph. Number 3, y is equal to -1/2 x plus 2 plus 4. A is equal to -1 because it's negative sign. B is equal to 1/2. H is equal to -2 because the 2 is positive. And K is equal to 4. So the horizontal asymptote is 4. It's the K value. The middle of my table will be my h value, which is -2. So to the left of that is -3 and -4. To the right of that is -1 and 0. So I'm going to plug all of these in. So -1/2, -4 plus 2 plus 4. So it's -1/2. -4 plus 2 is -2. So that's -4 plus 4, which is 0. 1/2 to the -2 is 4. -4 plus 4 is 0. Okay, next we'll plug in -3. So that's -1. 1/2 to the -1 is 2. So it's -2 plus 4, which is 2. Okay, next we'll plug in -2. -2 plus 2 is 0. So that's -1 plus 4, which is 3. All right, next we plug in -1. So -1 plus 2, that's 1. So that's -1/2 plus 4, which is 3.5. And then we'll plug in 0. Oh, whoops, that's 2. 0 plus 2 is 2. So that's -1/4 plus 4, which is 3.75. Okay, let's make a quick sketch. The asymptote is at 4. -4, 0. -3, 2. -2, 3. -1, 3.5. And 0, 3.75. So it looks like this. Letter A, above or below? Well, this is below the asymptote. Letter B, is this growth or decay? Well, it's below the asymptote. A is negative, so this is neither. C, the equation for the asymptote is 4. D, the domain is always -infinity to infinity. E, the range is below the asymptote, so it's going to start at -infinity and it's going to come up to the asymptote, which is at 4. F is the graph, which is right there. Number 4, y is equal to 3 to the x plus 3. Let's see. H and K. A is 1 because there's no number out here. B is 3. H is -3 because the opposite. And K, there's nothing here, so it's 0. Horizontal asymptote here is y is equal to 0. The middle of the table should be the h value, which is -3. To the left of that is -4 and -5. To the right of that is -2 and 1. I'm going to plug all of these in, starting with -5. So -5 plus 3, 3 to the -2, which is 1/9. Or you could just put it in a calculator, which I suggest, which is 0.1. Plug in the next one, -4, which is -1, which is 1/3, which is 0.3. Okay, next we'll plug in -3, which is 0, which is 1. Next we'll plug in -2, which is 1, which is 3. And then we'll plug in -1, which is 3 squared, which is 9. Now we can draw a sketch. Start with the asymptote, so it's at 0. -5, 0.1, which is like right here. -4, 0.3, which is a little bit above that. -3, 1. -2, 3. And -1, 9, which is up here. Letter A, this is above the asymptote. Letter B, this would be growth because it's above the asymptote and it's going up, so that's growth. B is larger than, A is positive and B is larger than 1. C, the asymptote is 0. D, domain is always -infinity to infinity. E is the range, so it's going up from the asymptote, so that's 0 and then up to infinity. And then F would be my graph, which is right here. Number 5 says express each in logarithmic form. So 4 to the third is equal to 64. So the base stays the same, so there's a log with a base of 4, but these two switch places, so 64 equals 3. Number 6, 3 to the -3 equals 1 over 27. So the base stays the same, so the base is still 3, except these two switch places, so 1 over 27, and that's equal to -3. 10 to the 4 is equal to p, so I take a log, the base stays the same, but these two switch places, so it's log base 10 of p is equal to 4. Number 8, express each in exponential form, so this is log base 6 of 216 equals 3. So the base stays the same, so it's a base of 6, but now these two switch places, so the exponent is 3, and that's equal to 216. Log the base of 1 over 8 of 64 is equal to -2. So 1 over 8 remains the base, except it's the base of the exponent, and now these two switch places, so -2, and that's equal to 64. So 1 over 8 to the -2 power is equal to 64. Number 10, log of 4 is equal to x. Now remember, if there's no base written here, you can assume the base is 10, so you can go ahead and add that here. So the base is 10. So the base stays the same, except these two switch, so 10 to the x is equal to 4. Number 11, it says solve for x. So 4 to the x plus 5 is equal to 10, 24. Now I'm going to take a guess and say that both bases can be expressed as 4. So 4 times 4 times 4 times 4 times 4, yeah. So that's 4 to the, 4 to the 5th power. So both bases can be expressed using a base of 4. So this becomes 4 to the 5th power. This is 4 to the x plus 5. Now that the bases are the same, the exponents can be set equal to each other. x plus 5 equals 5. Subtract 5, so our solution is 0. 3 to the 2x plus 1 equals 81 to the x. I'm going to use a base of 3 for these. So this already has a base of 3. This is 3 to the 4th power, I believe. Yeah, 81 is 3 to the 4th power. So this is 3 to the 2x plus 1 equals 3 to the 4x. Since the bases are now the same, I can set the exponents equal to each other. All right, subtract 2x to move it over here. So 1 is equal to 2x. Divide by 2. So solution is 1/2. 9 to the x minus 1 equals 1 over 81 to the x plus 2. So the base I want to use here is 9. So that already has a base of 9. 9 squared is 81, so 9 to the negative 2 is 1 over 81. Okay, so distribute this negative 2 to both of these. So 9 to the x minus 1 equals 9 to the negative 2x minus 4. And now bases are the same, so I can set the exponents equal to each other. X minus 1 equals negative 2x minus 4, and I can solve this. So move the x's to one side. There's 3x minus 1 equals negative 4. Add 1. 3x equals negative 3. Divide by 3. My solution is negative 1. Number 14, 4 to the negative x minus 5 equals 1 over 32 to the 2x plus 1. Now you might think that you should use a base of 4 here, but 4 is not going to work for 32. 4 times 4 is 16, times 4 again is 64. You actually have to use a base of 2 here. So 4 is a base of 2, it's 2 squared. And 1 over 32 is a base of 2, it's 2 to the 5th power is 32. So 2 to the negative 5th power is 1 over 32. Make sure you distribute for these. So 2 to the negative 2x minus 10 equals 2 to the negative 10x minus 5. Now I can set the exponents equal to each other. So negative 2x minus 10 equals negative 10x minus 5. All right, put the x's on the same side, so add 10x to both sides. So 8x minus 10 equals negative 5. Add 10 to both sides. 8x is equal to 5. Divide by 8. So our solution is 5 over 8. And then number 15, 1 over 8 to the x is equal to 1 over 32 to the x minus 1. Once again, we have to use a base of 2 here. 2 to the 3rd power is 8, so 2 to the negative 3rd power is 1 over 8. 2 to the 5th power is 32, so 2 to the negative 5th power is 1 over 32. Multiply. So 2 to the negative 3x equals 2 to the negative 5x plus 1. And then set the exponents equal to each other once the bases are the same. All right, move the x's to the same side. So we got 2x is equal to 1. Solve for x. So x is equal to 1/2. For 16 through 20, we are evaluating these logarithms. So the first one we have is log base 9 of 729. So first we set it equal to x, then we change it to exponential form. So that would be 9 is the base, but these two switch. So 9 to the x is equal to 729. I think 729 can be expressed using a base of 9. Yeah, it's 9 to the 3rd power. So this is 9 to the x equals 9 to the 3rd. And now that the bases are the same, set the exponents equal to each other. So log base 9 of 729, the value of that is 3. Log base 5 of negative 25. Okay, so you can't take a log of a negative number. That's just something we can't do. So this is undefined. Can't take a log of a negative number. It's not doable. Try it in your calculator, it won't work. Number 18, log with a base of 1 over 4 of 64. We'll set it equal to x, and we'll change this to exponential form. 1 over 4 to the x is equal to 64. Use the same base here, which would be a base of 4. So this is 4 to the negative 1 power. And I believe that's 4 to the third power. Yeah, 4 to the third power. So multiply 4 to the negative x equals 4 to the third. Now that the bases are the same, we can set the exponents equal to each other. Negative x is equal to 3. Divide by negative 1, x is equal to negative 3. So the value of log with a base of 1 over 4 of 64 is negative 3. Number 19, log with a base of 64 of 1 over 8. So set it equal to x. Change it to exponential form. So 64 to the x is equal to 1 over 8. I want to say 2 is what we're going to have to use here. 2 to the 6th power, yeah, so we have to use a base of 2. This is 2 to the 6th power. And 2 to the 3rd power is 8, so this is 2 to the negative 3rd power. All right, so multiply. 2 to the 6x equals 2 to the negative 3. Now the bases are the same. We can set the exponents equal to each other. 6x equals negative 3. Divide by 6, x is equal to negative 3 over 6, which is negative 1/2. So the value of log base 64 of 1 over 8 is negative 1/2. And the number 20, log with a base of 1 over 8 of 1 over 5/12. Set this equal to x, change it to exponential form. So 1 over 8 is the base, raised to the x power equals 1 over 5/12. I want to say that 8 will work for this. 8 to the 3rd power, yeah, a base of 8 will work here because 8 to the 3rd power is 5/12. So 1 over 8, that's 8 to the negative 1 power. 1 over 5/12, so that's 8 to the negative 3rd power. All right, so multiply negative x equals 8 to the negative 3. Set these equal to each other. Negative x equals negative 3. And then divide by 1 to solve for x, so x is equal to 3. So the value of this, log base 1 over 8 of 1 over 5/12 is equal to 3. All right, sorry for going a little bit fast there, but I'm a little low on time for this video, so hopefully you gathered everything or can pause along the way.